Hey guys. So today we are going to be going over the distance and the midpoint formula. And I wanted to do a video, so I think it would probably help you guys on what we're trying to do. So basically, we are going to use the Pythagorean theorem, and we are going to find the distance and the midpoint and the slope formulas basically using the Pythagorean theorem. So let's get into what I'm talking about. So if you are looking on page 476 in your book, you can follow along with me. But they give some points on the graph. They have an A, a C, and a B point. I'm not going to do all the hashtag marks. It makes it a little confusing, but I'll give you the points there. And so the A is going to be this point. It's not exactly to scale, but let's say it's 3, 2. So back 3 and then up 2. And then our point C is 4, 2. And our point B is 4, 6. You can see that. Okay, so if we find the distance between points A and B, we can draw this right triangle like I've done, and points A and C lie on this horizontal line, and the distance between point A and C is going to be the absolute value of the difference of their x coordinates. And then points B and C are going to lie on the vertical line, and the distance between points B and C is the absolute value of the differences of their y coordinates. So if we're looking for that, then the lengths of the legs of this triangle ABC, is going to be like this. We're going to take AC, so AC, and we're going to say that it's 4 minus a minus 3, the absolute value, okay? So that's taking 4 minus a minus 3. And that is going to give us the absolute value of 7, which is 7. And then if we take the points BC, we're going to take the absolute value of 6. Oops, can you see that there? 6 minus 2, the absolute value of 6 minus 2, which is going to be the absolute value of 4, which is 4. So what we basically did was take, from BC, we took our 6 minus 2, and that gives us 4. So because A and B are the length of our hypotenuse, this would be the hypotenuse in this right triangle, the segment that is across from our right angle, the hypotenuse, of the triangle. So we can then use the Pythagorean theorem to find what A and B is. Okay, so we figured this out. We've got a 7 and a 4. So we are going to remember that. I don't have enough space on this board here. So we are going to say that AB squared is going to be the same thing as AC squared plus BC squared. So it's like we're doing the Pythagorean theorem again, right? So AB then is going to be the square root of AC squared plus BC squared. See what I did? If this is squared, we're going to get rid of this. So we're going to take then the square root of that, of our whole term over here. We take the square root of AB, that's going to cancel out this raised to the second power. And so then we'll just have this, We're going to do the same thing that we do on one side, we're going to do on the other side. So this is going to be then the square root of AC squared plus BC squared. So we can get rid of this 2, the second power. And so since we already knew from up here, we said that AC, if you remember, is 7 and BC is 4. Now we can plug this in. So AC squared, so AB is going to be equal to 7 squared plus the square root also. All of that's the square root of 4 squared. And that is going to give us the square root. If you work this out, 7 squared plus 4 squared is going to give us the square root of 65. So AB is the square root of 65. Okay? So this is what we call the distance formula. So the distance between 2 points in a coordinate plane is equal to the square root, which is what we did, the square root of the sum of the horizontal change squared and the vertical change squared. Okay? So that's exactly what we did here. I need my eraser, y'all. So if you write this down, the distance formula is, D stands for distance, the square root of your x coordinates squared plus your y coordinates, the difference of your y coordinates squared. That's just what we just did on that last example. Okay? So let's give you another, let's use this formula here and find the distance between 2 points. Okay, so look at example 1 in your book on page 477. We have a point M. You know what? I'm going to erase this yet again. I'm starting to run out of room. So if we have a point M, we're trying to find the distance between these 2 points. So the distance, the point M, sorry about my children screaming, 6'3", and N is 5'7". So these are 2 points right here. 6'3", this is the coordinates. Remember, your first coordinate is your x coordinate, the second coordinate, or the second number is your y coordinate. So same here. So we're going to use that same formula. D equals the square root of x squared minus x1 squared plus y squared minus y to the first one there squared. So all we're going to do basically is just fill in our numbers. So the distance is going to be equal to 5 minus 6 squared 7 minus 3 squared. So all we did basically is take these first coordinates, 5 minus 6, these are our x coordinates, added 7 minus 3, and squared both of those. That is going to give us, hold on guys, can y'all please be quiet? Okay, so that is going to give us -1 squared, 5 minus 6 is 1, plus 4 squared. That is going to give us 1 plus 16. -1 squared is just 1, plus 4 squared is 16. And that is going to give us the square root of 17. So we took these 2 points, applied the distance formula, and then we came up with our answer of square root of 17. That means the distance between the points M and N is approximately the square root of 17 units. Okay? So that is all I'm going to give you today. We're going to take this kind of slow. We're just going to use the distance formula of these points. And I'm going to give you some problems to work those out. And then we'll move forward doing a couple of other points in this section with the midpoint as well. So we'll probably do that tomorrow. But today we're just going to focus on the distance between our 2 points and how we actually apply the distance formula to our work. Hope you can see that. Again, let me know if you have any questions, and I will put the work that I'm assigning on campus, and we'll have you do that today, and we will discuss it tomorrow. Have a good night, y'all.